Good morning students. Welcome back to Science Online class. In the previous class, we have learned about how our ears catch sound, what are the characteristics of sound and the speed of sound. Shall we revise the portion? How our ears catch sound. The sound vibrations from a source propagate through the air and reach our ears. Our ears actually hear these sound vibrations. The ear can be broadly classified into three parts. What are the three parts, ma? The outer ear, the middle ear and the inner ear. Okay, what are the three parts of the ear? The outer ear, the middle ear and the inner ear. Outer ear. The part of the outer ear that is visible to us is called pinna. We can see our outer ear. What is the name? The outer ear is otherwise called pinna. The pinna collects sound waves and directs them to the ear tube. The pinna collects sound waves and directs them to the ear tube. At the end of the ear tube is the eardrum. At the end of the ear tube is the eardrum. That is called tympanum. Eardrum is otherwise called tympanum. The eardrum vibrates when sound waves strike it and transmits the sound to the middle ear. The eardrum vibrates when sound waves strike it and transmits the sound to the middle ear. The next one, middle ear. The middle ear is a cavity with three important ear bones. The middle ear is a cavity with three important ear bones. These three bones are placed in such a way that they move when the eardrum vibrates and therefore transmit the vibration to the inner ear. The three bones are placed in such a way that they move when the eardrum vibrates. When the eardrum vibrates, the three bones will move. Therefore, transmit the vibration to the inner ear. The next one, inner ear. The inner ear connected to the middle ear through a small opening. The inner ear is connected to the middle ear through a small opening. The inner ear is filled with a fluid. The inner ear is filled with a fluid. When this fluid vibrates, it excites tiny hair in the inner ear. When this fluid vibrates, it excites tiny hair in the inner ear. These hair transform the vibrations into electrical impulses. These hair transform the vibrations into electrical impulses which are then transferred to the brain through the auditory nerve. This is how we hear a sound. Okay, ma? The next. What are the characteristics of sound? What are the characteristics of sound? Amplitude, time period, frequency and pitch, amplitude and loudness. What are the main characteristics of sound waves? Amplitude, time period and frequency. Okay, amplitude, time period and frequency. First one, amplitude. What is amplitude? The maximum displacement of the bob from the mean position during oscillation is called the amplitude of the oscillation. What is amplitude? The maximum displacement of the bob from the mean position during oscillation is called the amplitude of the oscillation. All of you see the picture, mean position, one extreme position B and another one extreme position C. So that is the maximum displacement of the bob from the mean position during oscillation is called the amplitude of the oscillation. Next one, time period. Time period. The time taken to complete one oscillation is called the time period of the oscillation. What is time period? The time taken to complete one oscillation is called the time period of the oscillation. What is the unit of time period? It is measured in seconds. Okay. The next one, frequency. What is frequency? The number of oscillations per second is called the frequency of oscillation. What is frequency? The number of oscillations per second is called the frequency of oscillation. What is the SI unit of frequency? Hertz. What is the SI unit of frequency? Hertz. The next one, frequency and pitch. Frequency is considered an important characteristic of a sound wave because different frequencies sound different to us. Shrillness is explained using a term called pitch. Higher the frequency of the vibrating body, higher will be its pitch. A high-pitched sound appears shrill and a low-pitched sound appears deep or gruff to our ears. Gruff means what, ma? Rough. Okay, rough to our ears. The next one, amplitude and loudness. If the amplitude is higher, the sound produced is louder. The loudness of a sound depends on the square of the amplitude. Then the loudness of a sound is measured in the unit called decibel. The loudness of a sound is measured in the unit called decibel. Okay, all of you clear? What is the unit of sound? Decibel. Okay, ma? The next, speed of sound. Sound waves travel at different speeds in different substances. Sound waves travel at different speeds in different substances. Sound waves travel fastest in solids and slowest in gases. Okay, sound waves travel fastest in solids and slowest in gases. Okay, all of you take your book, turn page number 180. First question, let's remember. First question, did you see page number 180? Let's remember. Write T for the true and F for the false statements. Correct the false statements. Okay. First one, objects that produce sound are called sources of light. Is true or false? Yes, false, isn't it? So you correct the sentence. Objects that produce sound are called sources of sound. Strike out the word light and write there sound. Okay. Second one, sound can be defined as a rapid back and forth movement of a body about a central position. Sound can be defined as a rapid back and forth movement of a body about a central position. True or false? Yes, true. Third question, the organ in human beings that is involved in the production of sound is the eardrum. the organ in human beings that is involved in the production of sound is the eardrum. Yes, right, true. Fourth question. Vocal folds are thin membranes stretched across the middle ear. Vocal folds are thin membranes stretched across the middle ear. Yes, statement is wrong. So you write there false. You stretched across the windpipe. You strike the word middle ear and write there windpipe. Okay. Then fifth question. Auditory nerves transfer electrical impulses from the ear to the brain. Whether the statement is correct? Yes, the statement is correct. So you write there true. Okay, ma. Wrong statement means you have to correct it. It is correct statement means you write there true. Once again, first one false statement. Instead of light, you have to write sound. Okay. Second one true statement, correct statement. Then third one true. Fourth one instead of middle ear you write windpipe. Fifth one correct statement. The next one, answer the following questions orally. First one, can an oscillating pendulum produce sound waves? Pendulum produce sound waves? No, isn't it? So write there no. Second question, is the speed of sound greater in water or in air? Speed of sound greater in water or in air? Say the answer. Yes, water. Okay, speed of sound greater in water. Okay, ma? Okay, today we are going to learn about types of sound. Sound can be of different types: soft, loud, pleasant, unpleasant, musical, audible. Audible means it can be heard. Inaudible means cannot be heard. Okay. The sound produced when an aeroplane takes off is both loud and unpleasant. When an aeroplane takes off, it will produce sound that is unpleasant to our ears. The next, the sound produced by a marble cutter. All of you know, isn't it? The sound produced by a marble cutter, how the sound will be produced there? Whether it is pleasing to your ears? No, isn't it, ma? So that sound is irritating and unpleasant. Okay, irritating and unpleasant. Now, audible and inaudible sounds. Audible and inaudible sounds. All bodies that vibrate in air produce sound waves. Okay, all bodies that vibrate in air produce sound waves. We cannot hear all of them. Some sound we can hear, some of them we cannot hear, isn't it? The next, our ears are sensitive only to a certain range of frequencies. Our ears are sensitive only to a certain range of frequencies, that is 20 Hz to 20,000 Hz. 20 Hz to 20,000 Hz. We cannot hear sound waves of frequency below 20 Hz and above 20,000 Hz. We cannot hear sound waves of frequency below 20 Hz and above 20,000 Hz. Dogs have the ability to hear very high pitched sounds, which we cannot. Dogs can hear the sound with the high pitched, but we cannot hear. Sound waves of frequencies below 20 Hz are called infrasonic waves. What are infrasonic waves? Sound waves of frequencies below 20 Hz are called infrasonic waves. All of you clear, ma? What are infrasonic waves? Sound waves of frequencies below 20 Hz are called infrasonic waves. Okay. Then the frequencies above 20,000 Hz are called ultrasonic waves. The frequencies above 20,000 Hz are called ultrasonic waves. Now all of you clear what is infrasonic and what is ultrasonic waves? Then human beings cannot hear these sounds. We also cannot hear the sound waves if they are too feeble. So human beings can hear the sound of frequencies ranging from 20 Hz to 20,000 Hz. Okay, 20 Hz to 20,000 Hz. Below 20 Hz and above 20,000 Hz, human ear cannot hear. Okay, ma? Now all of you clear what is audible and inaudible? All of you clear? Audible and inaudible? Okay. The next one, musical instruments. We find certain sounds pleasant and associate them with music. The sound coming from the musical instruments are pleasing to our ears. Okay. Broadly, the musical instruments are classified into three categories. Musical instruments are classified into three categories. First one, stringed instruments. First one, stringed instruments. Second one, wind instruments. Third one, percussion instruments. Okay, ma? What are the three categories? Stringed instruments, wind instruments, and percussion instruments. Okay. First one, stringed instruments. Can you say a few examples for stringed instruments? Yes, guitar, sitar, veena, piano, and violin. Okay, these are examples for stringed instruments. Okay, these instruments produced sound by vibrating string. Okay, how the sound is produced here? By vibrating the strings. Okay, the shrillness or pitch of the sound is altered by changing the length of the vibrating portion of the string. How the pitch is changed here? By altered to change the length of the vibrating portion of the string. Okay. For example, a sitar player plucks the string with the right hand. What he is doing? A sitar player plucks the string with the right hand while the pitch of the sound produced is changed by pressing the string with the index finger of the left hand. Okay. These instruments also have an air chamber which helps increase the loudness of the sound produced. Okay, these instruments also have an air chamber which helps increase the loudness of the sound produced. So now all of you clear, I think. Stringed instruments. The next one, wind instruments. Can you say a few examples? Saxophone, harmonica, flute, and trumpet. Here, how the sound is produced? The sound is produced by the vibrating air column inside the instrument. Sound is produced by the vibrating air column inside the instrument. Okay. The pitch of the sound is altered by changing the length of the vibrating air column. Stringed instrument, how the sound produced is changed? The length of the string. isn't it? The length of the vibrating portion of the string. In wind instruments, the pitch of the sound is altered by changing the length of the vibrating air column. The next one, percussion instruments. Percussion instruments. Can you say few examples? Tambourine, kadam, tabela, drums and dolak. These are the examples for percussion instruments. Okay, ma? Here the sound is produced by the vibrating skin or membrane. The sound is produced by the vibrating skin or membrane. The pitch of the sound is altered by increasing or decreasing the tension in the membrane. Okay, here the sound is produced by the vibrating skin or membrane. The pitch of the sound is altered by increasing or decreasing the tension in the membrane. Okay, this much enough today. We can mark 2 or 3 question answers. Okay, ma? All of you take page number 177. Page number 177. Roman number 4, second question. Roman number 4, second question. Explain briefly how we can hear our ears. Page number 177. How our ears catch sound, side heading. First paragraph, second line. The ear can be broadly classified into 3 parts. The outer ear, the middle ear and the inner ear. From there to last paragraph. Inner ear. These hair transform the vibrations into electrical impulses which are then transferred to the brain through the auditory nerve. This is how we hear a sound. Roman number 4, second question. Did you mark, ma? Roman number 4, second question, page number 177. Then page number 178. Roman number 3, third question. Roman number 3, third question. What is amplitude of a vibration? What is amplitude of a vibration? Page number 178, last paragraph. The maximum displacement of the bob from the mean position during oscillation is called the amplitude of the vibration. Did you mark the answer? Page number 178, Roman number 3, third question. Last paragraph, last 3 lines. Okay. The next one. Roman number 4, third question. Roman number 4, third question. What are loudness and pitch of a sound? What physical characteristics are they related to? Page number 179. Page number 179. Frequency and pitch side heading. Sound waves are produced due to the to and fro oscillation of particles in a medium. From there to that paragraph last. Pitch sound appears deep or gruff to our ears. Then amplitude and loudness side heading. The amplitude of the vibrating body producing the sound determines the loudness of the sound. From that to the loudness of a sound is measured in the unit decibel dB. Roman number 4, third question. Roman number 4, third question, page number 179. Did you mark the answer, ma? Then page number 181. Page number 181. Question. What are infrasonic and ultrasonic waves? Give their approximate frequency ranges. Roman number 4, fourth question. Roman number 4, fourth question. Page number 181. Page number 181. Audible and inaudible sound side heading. Fifth line. Our ears are sensitive only to a certain range of frequencies, 20 Hz to 20,000 Hz. From there to last line. We also cannot hear sound waves if they are too feeble. Roman number 4, fourth question. Roman number 4, fourth question. Did you mark the answers? Study the answers properly. Remaining we can see in the next class. Okay, ma? Thank you.